In this video, we will continue from the Crestron Drivers Project setup video and work towards building our driver structure. At this point, the project is created and our JSON file added as an embedded resource. Looking at the description from developer.crestron.com, we see there is a structure of classes required for driver creation. While the distribution of classes can vary between drivers, we will have only two .cs files encapsulating these requirements. Our main and transport classes will be handled in one .cs file, and our protocol and validation classes in another. We will set up and name each .cs file appropriately, and define our using statements required for our completed driver. We will be naming our .cs files based on their primary function, and including the using statements most appropriate for the type of device driver we are creating. If you would like to learn more about each individual namespace, there is C# API documentation at developer.crestron.com. In our main class, we start to gain access to the basic driver class functionality by inheriting from a device type specific class. For display or projector, we use basic video display. We see that basic video display has a parameterless constructor. This means that within our main class, we can use the default constructor or leave it out as it is implied. All driver types inherit from basic driver, and there are properties within that need to be set with our protocol and transport class information. We will complete this later. Furthermore, as seen in the list below, basic driver will handle multiple key portions of the driver framework. We will enter a default constructor as a placeholder for future logic. Since this driver will be communicating over TCP, we will need to implement the iTCP interface to get the appropriate initialize method for our chosen transport. The red line below the iTCP interface lets us know that we have not yet defined the required initialize method. IntelliSense can assist with adding this using the Alt-Enter key combination. Within this method, we will eventually assign objects to the connection transport and the display protocol properties required by basic driver to function. Now we will set up our protocol and validation classes. Our protocol class requires inheritance from a device type specific protocol class. Similar to the basic video display for our main class, this class will inherit from display protocol for displays and projectors handling specifics of the display device API. Examining display protocol shows that its constructor requires a serial transport and an ID value passed in, so our protocol's constructor will do the same. Using colon and the keyword base allows us to pass these required parameters to the display protocol constructor parameters. Lastly, we'll define our response validation class for processing the responses from the device. This will inherit from response validation which has a constructor that accepts a parameter of type data validation. We have now established the framework we'll use for our driver. The response validator will deal with the messages coming back from the device. Our driver's protocol class allows us to connect to our framework's protocol. Finally, our transport initializer will allow us to pass our communication settings to the underlying framework and initialize the protocol for our device. In our next video, we will complete the initialization phase for our driver. Thanks for watching.